To be able to solve a quadratic inequality, you need to remember the shape of a quadratic graph, because that will really help you to find the regions that you're looking for when you try to solve these. Hopefully you all remember that a quadratic equation is shaped like a parabola, and if the x squared part of your quadratic equation is positive, then you have a parabola that looks a bit like a bucket, and if the x squared part is negative, then that means the parabola shifts upside down, it flips upside down, so you have an unhappy one, or you have a hill shape. So you need to remember this in order to be able to solve these. So the first one we've got to look at is reasonably straightforward. It's x squared plus 9x plus 18 is less than or equal to 0. First of all, we need to find the roots of that equation. And we do that in the normal way. We factorise and we work out what the solutions are for x. And they're the points at which these graphs pass the x-axis. Fairly straightforward, looking for two numbers, multiply to make 18, add to make 9. Hopefully you work out that's 6 and 3. So we can rewrite this equation, x plus 6, x plus 3. Keep the inequality the same. Now what this means for this graph is that the graph cuts the x-axis when x equals minus 6 and when x equals minus 3. So if we were to sketch this graph, quite simply, it's going to look, make sure we've got enough room on the left-hand side. We've got minus 6, minus 3. Apologies for sketching with a pen, that's very naughty. That's rubbish, but you get the idea. Parabola goes through minus 6, goes through minus 3. The point of intersection with the y-axis is always the part of the equation that hasn't got an x involved, so that's going to be 18. Label your x and y. Now we're looking for the region where this equation, this graph, is less than 0. And that occurs when the graph is below the x-axis, i.e. y is less than 0. So that's this point here. So the solution to this equation occurs in this region. So all we need to do to solve it is write this region as an inequality. So we've got minus 6 less than or equal to, keep the inequality strict, x minus 3. So that is the solution to the first example. Let's try a slightly harder one. So our second example, a bit nastier, quadratic. Okay, now hopefully from last week you should all be really amazing at solving these harder quadratics. So we're looking for two numbers, multiply to make minus 15, add to make 14, and I'll pop that into the grid to try and factorise. So I've got 3x squared minus 5. Two numbers, multiply to make minus 15, add to make 14, are going to be 15 and minus 1. So let's pop these in here, 15x minus x, and work out what goes in the grid around the outside. So we've got a 3x and an x. We're going to have a 5, and we're going to have a minus 1. Double check that that works. Minus 1 times 5 gives you minus 5. Yep, it does. So we can rewrite this equation here in its factorised form. X plus 5, 3x minus 1. And keep the inequality the same, so it's greater than or equal to 0 this time. Okay, so the roots of this equation occur when x is minus 5. I'm careful with this one. When x is positive a third, because 3 times a third, take away 1, will give you 0. Let's sketch this. X squared is 3, so that's positive, so we're looking at a U-shaped parabola. Sketch again, sorry it's in pen, minus 5, 1/3. Doesn't have to be any more accurate than that. Looking at the equation, minus 5 is where it cuts the y-axis. It's always a good idea to get that onto your graph as well. Again, absolutely useless sketch. We want to know where this curve lies above the x-axis this time, because we want it to be bigger than or equal to 0. So that's going to occur on these tail sections. That's going to be there and there. So our solution for x for this equation then is x is bigger than 0 when it is less than or equal to -5, or bigger than or equal to 1/3. Okay, final example. Number 3. Not very nice, this one. 16 minus x squared is less than or equal to 6x. Okay, you should spot straight away, hopefully, that it's not, we don't have a 0 either side of the inequality, so that's our first starting point. So we need to get everything onto one side of the equation. Be careful, our x squared is negative, which means our parabola is going to be the other way up. It's going to look like a hill rather than a bucket. So I'm going to start by taking away 6x from both sides to get the quadratic into the right form for solving. I'm going to pop the x squared bit first just by convention. I'm going to have minus 6x, and we've got a positive 16, and that's less than or equal to 0. So now we have a better starting point. Now, to factorise this, with this being negative, is a bit of a faff. You can factor out a -1, factorise normally and then put the -1 back in, or, if you're a scaredy cat like me and don't like these at all, use the formula. Or if you've got a fancy calculator, pop it in your calculator to get the solutions directly. Okay, if you use the formula on this with a is -1, b is -6 and c is positive 16, then the solutions will come out really easily, and you get the solutions of x equals -8 and x equals 2. I'm not going to waste time doing that for you because I know you can all use the quadratic formula. So these are our solutions to this equation. Now we just need to sketch it to work out what region this equation satisfies being less than or equal to 0. So we need a -8 and a 2 on our sketch. -8, 2. Now be careful this time, it's upside down. We know from our equation that it's going to cut the y-axis at 16, so pop that one on as well. We've got y and x. And we want the region where this graph is less than 0. So again, like the last example, it's going to be at the tail end, below 0 at those points. So our solution is x is less than or equal to -8 and x is bigger than or equal to 2. Okay, hope that helps.